Thank you very much. My name is Sekgoari Mapunya from the University of Limpopo, Department of Computer Science. So the title of my talk today is Investigating the Effectiveness of the Spectrum Sensing Data Falsification Attack Defense Mechanism on Cognitive Radio Ad hoc Networks. This is just the table of my content to look at the introduction, related work, evaluated schemes, simulation models, results, and conclusions. So cognitive radio networks was just proposed by Joseph Mittal as a solution to the problem caused by the ever-increasing number of wireless network users. So the technology, it works by allowing what is called secondary users to opportunistically make use of underutilized spectrum, radio spectrum. So just like now when we are at work, the TV spectrum is underutilized because most of the TVs are not functional in South Africa. So the cognitive radio network allow secondary users like cell phones and so forth to make use of the underutilized spectrum opportunistically. In making use of the spectrum opportunistically, what we mean is that when the primary user of that particular spectrum wants to make use of that spectrum, the secondary user have to evacuate that particular spectrum, allowing the primary user to make use of that spectrum without any interference. Therefore, cooperative spectrum sensing is one of the core aspect of this particular network, where the spectrum sensing is where the secondary users, before they can access the underutilized spectrum, they will sense the spectrum to check which one is at that particular time underutilized, meaning that the primary user is not in use of that particular spectrum. Therefore, after sensing, they share the information with each other, and that is known as cooperative. They cooperatively makes decision of the availability of the spectrum of the underutilized spectrum. Therefore, in cognitive radio network, we have two types of configurations of it, where we are looking at the centralized and decentralized. In the centralized is where the decision is taken from a central point, but when we are talking about the decentralized is where secondary users individually, they make decision about the availability of the spectrum. Therefore, this technology is still susceptible to security issues, and one of the major security issues here is known as spectrum sensing data falsification attack, where if in the network there is an availability of an attacker, the attacker, its main objective will be to really send falsified information to its neighbors or to other secondary users in that particular network. Therefore, this is a very serious issue that we really would like to look into. Therefore, in literature, there are several of the security mechanisms that are developed to deal with this particular problem. Therefore, in our study, what we are really doing is we are checking and we are picking the best security mechanism from the literature. We compare them and we draw a roadmap or a framework for future research. So we are looking at the related work. We have in number, in reference 1 there, where the authors they've proposed a scheme or mechanism known as a conjugate prior-based detection scheme. So this scheme, how it works in this way. It isolates false sensing report generated by malicious users so that secondary users can correctly detect the activities of a primary user. So the scheme handles the sensing report from secondary users as random variables, then consider the probability density function for the random variables through a method known as conjugate prior. So the conjugate prior detection scheme can also isolate false sensing report received from any misbehaving secondary users. When a sensing report is considered to be false, the sensing report is not included in the final decision making of the spectrum access. Number in reference to authors, they propose a detection bio-inspired consensus cooperative sensing scheme. This is the name of the scheme which they are proposing in paper 2 or in reference to. The scheme counter the spectrum sensing data falsification attack in a distributed manner, meaning that on each and every secondary user is where the attack is being thwarted. When there is a lack of a central entity in an infrastructureless cognitive radio network, users send spectrum bands and reports their local energy data to their neighbor. This is where we are talking about the cooperative spectrum sensing, where the users, they share information amongst themselves. Then from the reports gathered from all the users, each user then use a selection criteria to isolate reports that are likely to be from an attacker. So how it does that, the secondary user exclude the malicious users by calculating the mean value of the energy. So each node then compares its value with the ones from the neighboring nodes. The node with the most deviation is then regarded as an attacker. So these are just some of them. And from the literature, we chose these two. Number 1, the reputation-based and majority ruling scheme. Number 2, we chose the extreme studentized cooperative consensus spectrum sensing. So the reason why we chose these two, number 1, is because they're making use of what is known as energy detection, both of them. In energy detection is where the secondary users, they sense the spectrum looking at the energy level of the primary user of the underutilized spectrum. If the energy of the primary user is very high, it means that in that particular spectrum, the primary user is in use of that particular spectrum. But if the energy value is very low, it means that the primary user is not in use of that particular spectrum. And therefore, the other thing that led us to choosing these two is because they are both of them infrastructureless, meaning that they share the information amongst themselves without any assistance from a central or from a base station. They from there they take decision individually without any help of anything. So those are the reasons why we chose these two. And in trying to check their effectiveness or comparing their effectiveness, because from the literature they are considered as the best when they are compared to other schemes, but we are taking both of them. We are trying to compare to see which one of the two really is the best, because in literature where we have went through, they are considered as the best. But now we are taking the best and we are comparing them, trying to check which one of them is the best, and from there we draw a framework for future research. So this, in trying to compare them, we have compared them on a MATLAB simulation tool, where we looked at in different scenarios where we are having 25 secondary users in the network. That's the first instance. We are looking at a scenario where we are having 25 secondary users in the network. So in that network of 25 nodes, we looked at scenario number 1, where we are having 10% of the nodes in that scenario, where 10% of those nodes are malicious users or the attackers. And we looked at the second scenario where we are having 25 secondary users and 15% of those 25% of secondary users are malicious. And the third scenario, we are looking at 25 nodes in a network, but 25% of those total nodes are malicious users. Therefore, these are the results. Number 1, we looked at the misdetection probability, where we are looking at a scenario, or we are looking at an instance where the detection mechanism, they misdetect the attackers. So in looking at our graph, it is evidence that the ESCCSS outperform reputation-based and majority ruling scheme. And as you can see on the graph, as the number of malicious users are increased in the network, the reputation-based and majority ruling scheme, the misdetection probability increase. So it means that the reputation-based and majority ruling scheme in a network where we are having lots of malicious users, its performance really deteriorate in the fastest manner compared to ESCSS. So ESCCSS, it maintained, I can say, equilibrium, nearly equilibrium. It shows that the ESCCSS outperform the majority ruling scheme. So we are looking at the success probability, where we are looking at the success in detecting malicious users. Therefore, even in this metric, we can deduce from the graph, which is projected here, and we can see that the ESCCSS outperform the reputation-based and majority ruling scheme. And therefore, we looked at the false alarm probability, where as well it is evidence we can see that the ESCCSS outperform the reputation-based and majority ruling scheme. So the comparative evaluation result of these two schemes has shown that the SSDF, which is the spectrum sensing data falsification attack countermeasures, are also susceptible to the effects of the spectrum sensing data falsification attack, because when we looked at our results, both of them, they could not totally or in totality detect all the malicious users. So they are still susceptible, meaning that the wrong decision can still be taken in a scenario where this particular mechanism are at place. So as well, their performance degrades as the number of malicious users increase in the network. So therefore, from our result, we can deduce that there's still a need to develop a very robust and more resilient SSDF security scheme to better and improve the network performance. So number one, what can happen alternatively if a new scheme from the start is being developed? If it is not developed from the start, alternatively, the current best performing scheme, which is the ESCCSS, can be modified to enhance its performance. So now this helps us to really put aside the reputation and majority ruling scheme, and we really have to enhance the ESCCSS. Therefore, what can happen? We can make use of the machine learning techniques to enhance the performance of the ESCSS. So this is just our conclusion, or the conclusion of our talk, and these are our references. So thank you very much. Thank you very much.